Good morning, everyone. Let's have examples of compression member. In last two lectures, we have studied about the theoretical portion of compression member. In the design of compression member, we have to use maximum data from this steel table as well as IS 800 2007. So, for the designing of compression member or else analysis of compression member, we have one important page of IS 800, that is page number 34. On that page, they have given us the design compressive load PD is equal to AE into FCD. For that, we have to find out first effective area of our section, whether it is angle section, channel section, I section, or else built up sections like double angle, double channel, back to back, double channel, front to front, double ISA. This kind of sections also used in compression member that we have studied. So, for that we have to take effective area, and that effective area must be calculated from the page number 18 and 19. For that we have to first identify that our section is plastic, compact or semi-compact. That we have to finalize. If it is plastic, compact or semi-compact, then we can take effective area as our gross area, that is given in steel table. So this is the important thing, and remaining, that is FCD, that we can calculate it from the equation given in IS 800. So let's start with some examples of analysis. We know that in the case of analysis of compression member, that we have to just calculate it, that if we are using the angle, if we are using the channel section, then what is the capacity of taking load of that section, that we have to find out. That is called analysis. But whenever we are going to design of any compression member, that first we have to select the member. This is the major difference of analysis and design of compression member. So first we have to understand about the analysis, right? What is given over here? Determine the compressive strength of single angle ISA 100 by 100 by 8 mm at a rate 12.1 kg per meter, with length of the member is 2.5 meter. The ends of the member are hinged. Assume that the load is applied concentrically to the angle. Fy is equal to 250 megapascal. So here we have taken that angle section 100 by 100, means B and D both are 100, and the thickness of the member, that is 8 mm. So we have to find out the compression capacity of this angle section. So for that, as we know, first we have to consider that it is plastic, compact or semi-compact, and for this section we have to take data from the steel table. So open your steel table. In that case, first for ISA 100 by 100 by 8 mm, the area given in steel table, that is 1539 mm square, and the minimum radius of gyration. In the steel table we have 4 radius of gyration. From that we have to take smaller of radius of gyration. Why we are taking smaller of r here? Because our section in compression, it will be buckled from the minimum radius of gyration, that is called local buckling. So from the prevention of the local buckling, we have to consider smaller value, so we can design the higher value. Now section classification, and this section classification given on page number 18 and 19 in IS 800/2007. In that case, we have to take angle section. So the equation that given B upon T, D upon T and B plus D upon T, this value must be less than the given value in table. So B upon D, that is 12.5, which is less than 15.7 epsilon. Here D upon T, it is same 12.5, which is less than 15.7 epsilon. B plus D upon T, that is 25, which is less or equal to 25 epsilon. But what is epsilon? Epsilon is given on page number IS 800/2007. Not number 2. In that they have given us the equation. So epsilon is equal to 1 for this case. Now the epsilon is 1, so our value is less of this value, and this 3 value is the value of semi compact given in that table. So our section is semi compact. Now our section is safe during the failure of slenderness. Here our section is semi compact, not slender. If it is slender, then we have to cut off that section, but in this case the things is okay. So we can take gross area as a effective area. For a semi compact section, gross area is effective area. So effective area is equal to 1539 mm square. So first the effective area is calculated. Now the second thing, that is FCD. For the calculation of FCD, we have to take page number 34, and we have equations over there. For that we must have to finding out the KL, means effective length, and for the effective length we have to take equations for the different end conditions, which is given on page number 45 IS 800. So open that page and see, there is a number of equations. If in this case the both end are pin, and for that we have equation of KL is equal to 1.0 L. So here effective length LE, that is 2500 mm. Now as the member is concentrically loaded, the design of compressive strength is calculated as per the IS 800/2007, page number 34. So we have to calculate the FCC. right? This FCC is known as Euler's buckling stress, and equation for that pi square E upon KL by R whole square. We have R minimum, we have KL, right? So the equation, that is pi square into 2 into 10 raised to 5 divided by 2500 divided by 19.5 whole square. So we will get FCC, that is 120.09 Newton per mm square. Now the lambda, right? It is also important thing for the calculation of phi and all other things. We can take this lambda. So lambda, that is under root of Fy upon FCC. Now we have FCC and we have Fy. So we can get the lambda, that is 1.44. It is also given on page number 34. Now we have to calculate phi, and this phi equation is also given on page number 34. In this case, we have one unknown, that is alpha, and this alpha is value of one factor, and that factor is totally depending on the class of our section. So for the finalize this class of angle section, we have to see page number 44, and from that we can get the class of this angle section. Once we can get the class, from that class we will take this value alpha as 0.49, which is given on page number 35. So alpha for the class C, that is 0.49. We have to put this value in page number in equation number this. So after putting the all value, we have now alpha, we have lambda, all the things we have. So we will get alpha, that is 1.84. Now we have this alpha, so we will calculate our FCD, because in this FCD we have this kind of equation. For that we have to finding out alpha, phi, lambda, each and everything. So let's start. The equation given in page number 34, that is Fy upon gamma m0 divided by phi plus in the bracket phi square minus lambda square whole raised to 0.5. Now we have all the things. What is gamma m0? That we know, alpha and gamma. Gamma, that is given on page number 30 in IS 800. Now put all the values in the equation of FCD. So we will get something like this. So the FCD that is given and calculated by us, that is 76.13 Newton per mm square. So we have now FCD and AE. So the equation from the page number 34, that is design compressive strength, PD is equal to AE into FCD. AE that we have calculated just before, and FCD is here. So from this we will get the design compressive load, which is carried by the section that given 100 by 100 by 8 mm. Now what we will get? PD is equal to AE into FCD. That's why PD is equal to what we have, AE is equal to 1539 multiply with 76.13. So we will get 117,164 Newton. But whenever we are going to calculate the capacity that must be in kilonewton. So we have to convert this in kilonewton. That's why PD is equal to 117.16 kilonewton. Okay. Whenever we have this kind of case, we can calculate this FCD from another way, but it is applicable only when our load is applied concentrically. So you can see concentrically applied load is given in this case. So we can calculate directly that FCD from page number 42 for the class C from KL upon R. Let's see. For the understanding of this, I have take another example. What they have given? A leg of transmission line tower consists of an ISA 200 by 18 mm and 3 meter long. Calculate the compressive strength for the member considering load is applied concentrically. Whenever we have this kind of thing, then we can calculate it directly. Ends of the members are pin. Take Fy is equal to 215 megapascal. So, for the finding out the PD, first we have to finding out the A, and A we know that we can calculate it from the page number 18. First we have to take area and R minimum from the steel table. What is the area of this angle section? That is 6881 mm square, and R minimum, that is 39 mm. We have this one. Now open the code and see page number 18. We have to classify our section, and for that we have B upon T, that is 200 upon 80, which is 11.11, which is less than 15.7. Second, D upon T, again 11.11, less than 15 upon 7. B plus D upon T, that is 22. It is also less than 25 epsilon. So our section is semi-compact, so we can take gross area as a effective area. So effective area for this section, that is A is equal to 6881 mm square. Now effective length. Whenever the both ends are pin, the effective length KL is equal to 1.0, that is given on page number 45, IS 800. So again KL is equal to 1, that is 3000 mm. Now as the member is concentrically loaded, the design of compressive strength is calculated directly from the IS 800, page number 42 for class C. Here we have to take first class, that what class of our section, that is given on page number 44. If our class is A, then we have to take page number 39. If class is B, then 40. That is given on these pages. You can refer IS 800. So for the class C, we have to take page number 42. In that case, first we have to finding out the KL upon R, right? For the class C, refer page number 42 for finding out the compressive stress FCD. So first What is KL upon R? We have KL, that is 3000, divided by R minimum, that is 39. So it is 70.92. Now from this value for FY250 and page number 42, these three combinations and the interpolation of all the values, we will get FCD as a 140.93 Newton per mm square. So we can directly calculate this FCD from the given page. Now, but it is applicable only when our load is applied concentrically. So, dear student, after getting the FCD, we can calculate the design compressive load, that is PD is equal to A into FCD, multiply with these two value, we will get 969.3739. So, the load, that is 969.74 kilonewton. This much load can carry by the ISA 200 by 200 by 18. So, dear student, this is the analysis, but this is the case of only concentrically loaded column. What happening when the eccentrically loaded column? The calculation must be different. We can't calculate this FCD directly from the page number 42, and that we will discuss in next lecture. Till then, you refer just this example again and again. This is most important question for us. Thank you very much.